Welcome to The Explainer. Today, we're diving into one of the most mind-bending ideas in all of physics, and it comes straight from a recent paper on cosmology. It's the possibility that you, me, and everything we think is real is just a random cosmic accident. Get ready, because we're talking about the Boltzmann brain. So let's just jump right in with a thought experiment that's going to sound a little nuts, but it's got serious roots in physics. What if your entire life, everything, every memory you have, every person you love, every single thought, was a total illusion? What if you just blinked into existence a second ago, with all those memories pre-installed?
Well, that's the core concept of a Boltzmann brain. The idea is that over unimaginable stretches of time, in the endless random chaos of the universe, it's not just possible but statistically likely that particles could just bump into each other and assemble a perfectly functioning conscious brain. And this brain, it would have a complete, totally fake set of memories, convincing it that it had lived an entire life.
And here is where it gets really unsettling. From a pure numbers standpoint, it is way more probable for a single, small, organized thing like a brain to pop up randomly than it is for this entire, vast, incredibly ordered universe to have happened. So the paradox becomes, why should we believe we're living in the less likely option? How do you know for sure that you aren't one of those brains right now?
Okay, so how do we even begin to argue against this? Well, our best defense, our strongest alibi for reality, seems to be something we all take for granted every single moment of our lives: the fact that time only ever moves forward.
We see this rule absolutely everywhere. You can scramble an egg, but you can't unscramble it. Your room gets messy all by itself, but it never ever gets clean on its own. This relentless march from order to disorder, what physicists call increasing entropy, is what gives time its arrow. It's what anchors us to a consistent reality.
Now, the paper we're looking at gives this a formal name, the entropy conjecture. It models the universe's entropy as a stochastic process, which is really just a fancy way of saying it's random. But here's the key. It assumes the fundamental rules of physics don't care which way time is flowing. They work the same forwards as they do backwards.
This slide really helps frame the standard story of our universe, right? We think we started in this incredibly tidy, low-entropy state, way back at the Big Bang. And ever since then, we've been on a one-way trip toward more and more disorder, eventually heading towards a state of maximum chaos called heat death.
But here is the devastating catch. If those laws of physics really don't care about the direction of time, then our present relatively ordered moment is probably just a random dip in a vast ocean of chaos. And from a statistical dip like that, disorder should increase in both directions, not just toward the future, but toward the past as well. And that leads to a horrifying conclusion. Our memories of an ordered past are almost certainly fake. We are the fluctuation. We are the Boltzmann brain.
Okay, but that just feels wrong. Viscerally wrong. And that feeling forces us to dig a little deeper and question our own assumptions, which uncovers an even bigger problem. How do we even know the second law of thermodynamics is true to begin with?
The paper points out this massive vulnerability in how we think about, well, everything. Our entire knowledge of the universe is built on records and memories that only exist right now, in the present. Think about it. Textbooks, computer data, your memory of breakfast this morning. It's all stuff you're accessing in this moment.
Why do you believe in gravity? Because you remember seeing things fall? Or you trust the records of experiments done hundreds of years ago? Our entire belief in the laws of physics is built on a foundation of trusting the past.
And right here is where the whole argument eats its own tail. We use the second law of thermodynamics to say that our memories and records are reliable traces of a real past. But we only believe in the second law because we trust those very same memories and records. We're using the law to prove the evidence that proves the law. It's a perfect, unbreakable logic loop. So to break out of this circle, the authors say we have to stop relying on our gut feelings. We have to get super precise and use the cold, hard math of random processes to figure out what we actually know versus what we're just assuming.
So, if our everyday logic is stuck in a loop, what are the actual, formal theories competing to explain why we're here? The paper really boils it all down to two main contenders. First up, we have the past hypothesis. This is the standard view, the one you'd hear in any cosmology class. It's a belief that our ordered world today is the direct result of an even more incredibly ordered beginning. We're not just a random fluctuation, we're the product of a consistent 13.8 billion year history.
And this is where the paper's argument really lands. When you strip them down to their mathematical core, the Boltzmann brain idea and the standard past hypothesis look shockingly similar. They both make one giant,
unprovable assumption about a moment of low entropy. The only difference is when they make that assumption. The Boltzmann brainer bets on the present, and the cosmologist bets on the Big Bang.
You can see it laid out right here. Both theories basically nail down the universe's entropy at one specific moment in time. They just pick a different nail, and from a purely logical point of view, neither choice is automatically better than the other.
To really drive this home, the paper throws out this wild thought. What if the universe's most orderly moment was in the year 1000 AD? If that were true, all of history before then would be a fabrication, but everything since, the Renaissance, modern science, you name it, would be real. It shows this isn't a simple choice between real universe and fake brain. There's a whole spectrum of possibilities.
So, we seem to be trapped. If pure logic says a real universe and a Boltzmann brain are on basically equal footing, how on earth do we decide what to believe? This brings us to the paper's final and maybe most important question.
And here's the big reveal. The laws of physics can't save us. The laws are great at telling us how things evolve once they get started, but they're totally silent on which starting conditions we should pick. That choice, that fundamental leap of faith, is up to us. It all comes down to what evidence we decide to trust.
The authors do propose a way out, and it's all about good scientific practice. The rule is simple. You can't cherry-pick your data. If you have multiple pieces of evidence you believe are reliable, you have to use all of them. So we have good data about the universe's entropy now, and we have good data from cosmology pointing to a low-entropy Big Bang. You have to take both into account.
But when you do that, when you force the math to accommodate both a neat beginning and a neat present, you get a really strange answer. The most likely path between those 2 points isn't a straight line of increasing messiness. The model suggests entropy might have actually been higher in our recent past and has been decreasing to where we are now. It means the arrow of time might not be so simple after all.
And in the end, it all comes down to this. Our belief that we aren't Boltzmann brains isn't based on some unbreakable law of physics. It's based on how much faith we put in our telescopes, our particle accelerators, and our models of the early universe. We choose to trust the story of the Big Bang more than we trust the story of the random momentary fluctuation.
And that leaves us with one final, deeply unsettling thought. If the very existence of our past isn't a proven fact, but a choice we make to trust one set of data over another, what else about our reality is built not on certainty but on a choice of what to believe?